One of two ingredients in making steam is water. Once heated to its boiling point, tiny bubbles of steam form at the point of the most intense heat. The tiny bubbles rise to the surface, bursting as they leave the natural pressure of the water they come from. The instant water turns to vapor, unseen particles that are carried in the water are left behind. It's these hidden particles that become problematic for a steam boiler. It's not until a boiler is open for inspection after hours of operation that the particles' effect becomes evident. The bare metal of the boiler's interior has developed a white, plaster-like coating. In the bottom of the vessel is a thick mud. Scale, found coating the surfaces inside the boiler, has been insulating the expensive heat generated by the burner from the water. Under the coating of the scale are natural chemical reactions, creating corrosion sites that continue uninhibited due to the protective coating provided by the scale itself. The water is crystal clear. In most cases, the water has been delivered from a municipal treatment plant where it was purified. This demonstration will hopefully shed light on this mysterious formation within a boiler. 1,000 milliliters of tap water will be vaporized in a stainless pan in 100 milliliter portions. With each 100 milliliter addition, a measurement will be taken indicating the amount of hidden particles. This will show the increase in concentration, finally resulting in a visible residue left coating the bottom of the pan. First, the 1,000 milliliter beaker is filled with tap water. The beaker will allow exact additions of water. A device called a dissolved solids meter will be employed to measure the level of solids in each sample. The process begins by determining the level of solids found in the tap water. The meter indicates just over 200 microsims per centimeter. This is the method this particular meter uses to determine the concentration of dissolved solids in the sample. When converted, this measurement indicates there are 128 parts per million of dissolved solids found in the tap water. The first 100 milliliters of water is now added to the heated pan. Once the boiling process begins, the second 100 milliliters of water is added. Once this is rendered to approximately 100 milliliters, a measurement is taken. The meter indicates the concentration has doubled. Then the third 100 milliliters is added and the process continues. The measurement of the third addition indicates just over 500. With 3 additions, there should be over 600. This missing amount of dissolved solids is the first indication of a formation of solids on the surface of the pan. Now, the fourth 100 milliliters are added and the vaporizing process continues. The meter now indicates 600. Now the fifth addition is added and the process continues. The meter now indicates 700. The sixth addition is added. The sides and bottom of the pan are stirred to loosen any solids not bonded. Hopefully this will increase the amount of solids suspended in the water. The meter now indicates 1,000. This is still less than the 1,200 that has been added to the pan. The natural attraction of these solids to the intense heat being applied to the pan hold a portion of the missing particles in a thin layer. Other particles are deposited above the water line as the water sprays outward from the bursting steam bubbles. This is the exact process that goes on within a boiler. At the end of the 7th edition's rendering, the meter indicates 1200. Now the final additions are added as the process comes to an end. On the 8th edition, a clean brush is used to agitate the buildup within the pan. The meter shows the continued increase in concentrations. The final measurement indicates 1800. This indicates there are some 200 deposited around the interior of the pan. Looking closely, a white band of deposits are clearly visible above the water's surface. The water is now completely vaporized. With the pan cooled, a piece of black paper is wiped across the bottom of the pan to expose the accumulation of hidden particles contained in the water. It is evident that the water contains something. The white powder remaining is calcium. Calcium is the 5th most abundant element on Earth. 85% of the water systems in the United States contain some form of dissolved solids. Within a steam boiler, this accumulation can be devastating. Energy costs can be dramatically higher than necessary due to its insulating properties. Circulation within the boiler can be affected, leading to tube failure due to overheating. Corrosion can weaken the walls of the pressure vessel, resulting in premature replacement of the entire boiler. The quality of the steam produced can be problematic in the operation of the associated equipment. It's common to find supply lines to homes and businesses blocked by buildups of these hidden particles. This is nothing new. Hard water has always been delivered in Mother Nature. The proof is easily seen around the edge of Lake Mead in Nevada. For 80 years, calcium has built up on the rocky walls around the lake, leaving a white band that is visible from space. How is your water? How is your boiler? Interested in finding out more and preventing your own scale problem? Contact Cleaner's Mentor and let us help.